Hello students, this is Mr. Deaver, and in this video we're going to talk about neutralization reactions. Let's start with an example of how neutralization reactions are important in our everyday life. I'm sure that many of you have been to Chipotle, and so we all know that every time you go to Chipotle, what happens? This happens, right? You get an upset stomach. We're talking heartburn, indigestion, diarrhea, unwanted pregnancy, vomiting, nausea. I mean, every single time it happens. We've all been there. And how do we treat this stomach ache or this heartburn that happens every time we go to Chipotle? Well, we use an antacid. And an antacid is basically a base. So sometimes it can be calcium carbonate, which is a base, or milk of magnesia contains magnesium hydroxide, which is a base. So there's this idea, which I actually mentioned in a previous video, that acids and bases can counteract or cancel each other out or neutralize each other. Another example of this is with bee stings. Okay, bees inject a number of substances into our body, but some of those are acidic. And there's this idea out there that we can perhaps neutralize that acid by putting a base like baking soda onto our skin. Now, in reality, is putting baking soda on your skin going to neutralize that acid that's been injected inside your skin and is now in your cells and your bloodstream? I'm not sure. Maybe. Probably not, though. But it is interesting that I found out in my readings that while bee stings are a little bit acidic, wasp stings are actually a little bit basic. So maybe you could treat a bee sting by getting a wasp sting in the exact same place. I don't know. In any case, again, we have this idea that acids and bases can neutralize each other. Well, this is essentially what we call a neutralization reaction. This is when an acid and base react, canceling out their harmful effects to form some products. And let's actually think about what these products will be before I show you what they are. All right, now here's an example acid and base. We have hydrogen and some sort of anion in our acid and some sort of metal and hydroxide in our base here. And of course, when we put these in water, they're going to dissociate. They're going to split up into a positive H ion, some sort of negative anion, a positive cation metal, and a hydroxide ion. So what do you think the products here are going to be? For example, if we have an H plus and an OH minus and they react, what are we going to get? Water. What about our metal cation and our non-metal anion? What are they going to produce? They're going to form an ionic compound or a salt. So every time we react an acid and base, our products are going to be water and some sort of salt. So that positive hydrogen ion and the hydroxide ions react to form water, and the conjugate acid and base pair that we have here react to form a salt. So write this down in your notes, and then there's also a reading that I want you to do on neutralization reactions. You can either pause the video and do it now, or you can do it after the video. But right now, we're going to do a couple practice problems together to show you some examples. Let's start with number 1. We have HCl and NaOH. Now, to help us visualize what's happening here, I'm going to show you this dissociation. HCl is going to dissociate into H plus and Cl minus, NaOH into Na plus and OH minus. So what are the products going to be? H plus, OH minus are going to react to form H2O, or water. Na plus and Cl minus are going to react to form sodium chloride. Now, one thing you have to keep in mind here when you write the ionic salt is you have to write the correct formula. And that compound has to have a net neutral charge. So if we have Na plus and Cl minus, how many Nas do we need to balance out this minus 1? Well, just 1, right? And how many Cl minuses do we need to balance out 1 positive Na? 1. So that's not so bad, right? It's just going to be NaCl. 1 Na and 1 Cl, they have a net neutral charge. The second thing that can make this a little tricky is we're going to have to balance this equation by writing the correct coefficients in front of each compound. Now, we've talked about balancing, we've learned about balancing, but it was a while ago, way back in quarter 1. So we're going to review it quickly here and see if we can jog your memory. When we balance an equation, we have to make sure that there's the same number of each element on the left and right side of our equation here. So let's start by looking at the h's. How many h's are on the left? 1 here and 1 here. That equals 2 h's on the left. How many h's are on the right? 2. Okay, so they're actually already balanced. We don't have to do anything to make it so that there's the same number on each side. What about the CL's? There's 1 Cl on the left here, 1 Cl on the right. So they're also already balanced. 1 Na, 1 Na, they're balanced. 1 O and 1 O. So even without doing anything, there's already the same number of each element on the left and the right side. What does that mean we have to do? We're going to put 1s for all of our coefficients, right? If we have 1 HCl, 1 NOH, that's going to give us the same number of each element as having 1 H2O and 1 NaCl. Okay, let's do one more example together. Let's look at sulfuric acid and calcium hydroxide. Now, I didn't show the dissociation happening down here, but we know that this H and this OH are going to react to form water. And we know that calcium and sulfate are going to react to form calcium sulfate. But let's spend a bit more time on this one actually writing the correct formula for that ionic compound. Because again, this is something we've learned before, but it's been a while. And to write the correct compound, we have to know the charges. Up here, I gave you the charges, but what about if you don't know what the charges are? Well, one thing is we can use our periodic table. So we hopefully know that elements in the same column they form the same ions. They have the same charge when they form ions. So if you don't remember this, you need to review this. Everybody in group 1, those metals form a +1 charge. Group 2 forms a +2 charge. These form a +3 charge. -3, -2, and -1. If you don't know that, you need to review it. So calcium, which is here in group 2A, what charge will it have? It's going to have a +2 charge. Now, this is a polyatomic ion, SO4, or sulfate. We need to look at our sheet of common polyatomic ions. Here is SO4, sulfate. It has a -2 charge. So we need to make sure that the charges balance out. So how many calciums do we need to balance out a -2? Just 1. In fact, if we have just 1 of each, that's going to balance out. So we're going to have 1 calcium and 1 sulfate in our compound. All right. Also, another way that we do this sometimes is that we say that the number that we're going to have in the subscript here for one part of the ionic compound, we can get that from the number in the charge on the other compound. So we kind of switch these here and we say, hey, we're going to need 2 calciums and 2 sulfates, but we also know that if we have a situation like 2 and 2 or 3 and 3, we're going to simplify it to 1 and 1. So again, calcium sulfate, CaSO4. And of course, we're going to have to balance our equation here. So let's see. We have 2 H's and 2 H's here. So wait, that's 4 H's on the left side. On the right side, oops, there's just 2 H's. So what number do we need here to get 4 H's total? We need to put a 2 here because 2 times 2 is 4. So we're going to have now 4 H's on the right and 4 H's on the left. All right, let's look next at SO4, which as a polyatomic ion, and we see there's an SO4 here, and there's an SO4 here. It stays together, and there's one on each side. Easy. Calcium, there's one there, and one there. Okay, hydrogen, there's two, and then because we already put this 2 here, now we also have 2 oxygens on the right. So since everything else is balanced, we can finish by putting a 1 for all the other coefficients. Okay, there's one more thing that I want to show you, because both of those ionic compounds were pretty easy to write the formulas for. So let's do a more complicated one before we wrap up. Let's do aluminum sulfate and write the formula for that ionic compound. Let's first get our charges. Aluminum is here in column 3A. So aluminum has a +3 charge. Sulfate, we already saw on the last example that sulfate has a -2 charge. So I showed you the strategy of switching and saying how many aluminums do we need. We can look at the charge on the other piece to get aluminum's number, right? We're going to need 2 aluminums and 3 sulfates. Now, anytime that we have more than one of a polyatomic ion, what do we have to put? Parentheses. So we're going to have Al2, but then SO4 is going to be in parentheses with the 3 on the outside of the parentheses, because we need 3 of this whole thing. So that's a little review for writing ionic formulas and also balancing equations. There's some more practice for you. Good luck.